And this section is a comprehensive guide on Python variables. Here we will take you through the detailed exploration of how Python handles data storage and manipulation. Let's preview what we will be covering in this section. Naming conventions and best practices for variables, assignment operations for storing data, multiple assignment techniques for efficiency, typecasting for data conversion, type checking for verification, variable deletion for memory management, global variables for border scope, local variables for function level control. Let's begin with variable naming rules in Python. These guidelines are crucial for writing clean maintainable code. Python enforces several key rules for variable names. The variables must start with a letter or underscore. They can contain letters, numbers, or underscores. Special characters and spaces are prohibited. Names are case sensitive. Let's see these rules in action. Age assigns 21 demonstrate a simple integer variable. Underscore color assigns lilac shows us a underscore prefix. Total score assigns 90 illustrate combining words with underscores. And notice how one name would be invalid as it starts with a number. Next, let's explore Python's variable assignment system, one of its most powerful features. Python's assignment system is simple. It uses just the equal sign and it is pronounced as assignment. Dynamically typed, flexible enough to change types, and intuitive and straightforward, capable of handling multiple data types. Watch how easily we can assign and modify variables. X assigns 5 creates an integer. Y assigns 3.14 creates a float. Name assigns Alice holds a string. And we can even change X to store a different type, that is X assigns now a string. Python offers powerful multiple assignment capabilities that can make the code more elegant and efficient. With multiple assignment, you can assign several variables at once, unpack sequences into variables, swap values even without temporary variables, and initialize multiple variables with the same value, and even work with different data types simultaneously. Let's see multiple assignment in practice. X, Y, Z assigns 1, 2, 3 assigns 3 values at once. A assigns B assigns C assigns Python gives all variables the same value. Fruits assigns list of apple, banana, cherry. X, Y, Z assigns fruits that unpack the list into individual variables. Moving on to typecasting in Python, which allows us to convert data between different types. The typecasting provides several essential capabilities such as convert between different data types. They use built-in functions int, float, str and transform data for validation and processing, converts both basic data types seamlessly and handle type conversions efficiently. Let's see typecasting in action. X assigns 10 starts with an integer. Float underscore x assigns float of x, converts the float, giving us 10.0. str underscore x assigns str of x, transforms to string. Complex underscore x assigns complex of x, creates a complex number, that is 10 plus 0j. Bool underscore x of assigns bool of x, converts boolean, that is true. Notice how Python provides a seamless pathway between different data types, allowing us to transform data as the need of our programs. Type checking is crucial for understanding and verifying the data types in our Python programs. The type function offers several advantages. To work with all Python data types, provide immediate type verification, helps in debugging and testing, returns the exact class of the variable, essential for type-sensitive operations. Let's examine the type checking in practice. N assigns 42, F assigns 3.14, S assigns hello. Li assigns 1, 2, 3 makes a list. Print the type of N shows us it's an integer. Print the type of S, confirm it's a string. Understanding variable types helps preventing errors and ensures the code works as intended. Next is variable deletion. Python provides a clean way to remove variables from the memory using the del keyword. Variable deletion is important because it frees us the memory resources, prevents accidental variable usage, works with individual variables, handles collection elements, and helps to maintain clean code structure. Watch how the variable deletion works. X assigns 10 creates our variable. Print x shows the value exists. Del x remove the variable. And if we try to print x again, we will get a name error. The del keyword completely removes the variable from memory, helping to manage program's resources. Next, the global variables provide program-wide accessibility. They are defined outside of any function. They require the global keyword for modification. They share data across different scopes and persist throughout the program execution and need to be careful management to avoid the side effects of using the global variables. Let's see the global variables in action. Total assigns 100 defines our global variable. Next, the function def update total creates a function. Global total declares the intended to modify the global. Total plus assigns 50 updates the global variable, and outside the function we are calling the function update total, and print total shows the new value of 150. The global variable provides a way to share data across the entire program. Finally, let's explore the local variables, which are fundamental to function level encapsulation. They are powerful because they exist only within their function. They get destroyed after function completion and prevent naming conflicts naturally, promote better code organization, and enable clean function level data handling. Here is how they work. Def calculate square of x defines our function. Results assign x into x creates a local variable. Return result, return the calculation. Next, outside the function, square assigns calculate square of 5, calls the function, and when we print the result outside, raise an error, since we cannot access the local variables outside the function. The local variables ensure that the function remain independent and self-contained, promoting better code organization. Let's summarize what we have learned about the Python variables. Remember these key concepts: flexible variable creation and naming, dynamic type handling for versatility, advanced type manipulation capabilities, effective scope and memory management. Practice these concepts in your own code to become more proficient in the Python program.